Hello students, today we are going to continue the refraction of light and its uses. But before we proceed with our topic for today, we are going to learn some new vocabularies. First, prism. Again, prism. Let's spell prism. P-R-I-S-M. Prism. Next, wavelength. Again, wavelength. Let's spell wavelength. W-A-V-E-L-E-N-G-T-H. Wavelength. Next is spectrum. Again, spectrum. Let's spell spectrum. S-P-E-C-T-R-U-M. Spectrum. Now let's review some lessons from the previous lesson that we have. What is refraction? Can you answer? It is the bending of light as it passes through different materials. Again, it is the bending of light as it passes through different materials. What is the index of refraction for water? Can you recall? The index of refraction for water is 1.33. Next, what is the index of refraction for glass? Still remember? The index of refraction for glass is 1.5. Okay, let's continue with our discussion regarding the refraction of light and its uses. When white light enters a prism, each wavelength of light is refracted by a different amount. The longer the wavelength, the less it is bent by the prism. Red, with the longest wavelength, is refracted the least. Violet, with the shortest wavelength, is refracted the most. But what is a prism? A prism is a three-dimensional shape with two identical shapes facing each other. These identical shapes are called bases. The bases can be a triangle, square, rectangle, or any other polygon. Other faces of a prism are parallelograms or rectangles.
In this video, we try to understand one of the most interesting three-dimensional shapes. It's called a prism. Most people think of a prism as something like this, but have no idea about its correct definition. So let's erase this and start with the definition of a prism. It's a three-dimensional shape that has identical parallel ends and all flat faces. Well, it's the most confusing definition ever. Identical, parallel, flat, there are just too many things. So forget the definition for now. Let's just look at figures and understand prisms. Look at this three-dimensional figure. The most important thing in topic of three-dimensional shapes is visualizing the shapes. Few of the lines are dotted because those are the lines that cannot be seen from this view. Look at the ends of this figure. It's a long figure with two ends. Now let me color the two ends for you. This figure has two triangles at its ends. And it has three rectangles as faces. This one in the front, one at the back, and one at the bottom. Now we look at the definition. It says that the ends are identical and parallel. They are identical since both are triangles, and both the triangles are parallel to each other. The definition also says that all its faces should be flat. And in this figure, all faces are flat, they are rectangles. This, by the way, is called a triangular prism. Here's another three-dimensional shape. Let me color its ends. We can see that it has two rectangles as ends and they are also parallel to each other. And it has four rectangles as faces. One on the right hand side, one on the left hand side, one at the top and one at the bottom. So all its faces are flat. This is called a rectangular prism. So if you noticed, the prisms are defined by its ends. Triangles as its ends, triangular prism. Rectangles at its ends, rectangular prism.
The difference in refraction causes the white light to spread out into all the visible colors: red, orange, yellow, green, blue, and violet. The same process occurs in water droplets in the air. When white light from the sun shines through the droplets, a rainbow may appear. The water droplets act like tiny prisms, refracting the white light into all colors of the five visible spectrum. What is a spectrum? Light spectrum can mean the visible spectrum, the range of wavelengths of electromagnetic radiation which our eyes are sensitive to.
The sun generates tremendous amounts of energy. Energy travels through space in waves. These waves come in many different wavelengths. A wavelength is the distance from the top of one wave to the top of the next. The shorter the wavelength, the more powerful the energy. The sun gives off many short wavelengths. Some of the more powerful wavelengths of energy, such as ultraviolet energy, gets absorbed by the Earth's atmosphere, which is good because too much of the shorter wavelengths of energy would make it impossible for life to be present on Earth. Some of the sun's energy that comes through the atmosphere is invisible to us. Human eyes can only see a small portion of sun energy. This is called the visible spectrum. As it turns out, this makes up a large portion of the energy that makes it to the Earth's surface. Humans can see energy that range in wavelength from 380 nanometers to 700 nanometers. A nanometer is 1/billionth of a meter. For example, a human hair is about 90,000 nanometers wide. Within the visible spectrum, we see different wavelengths as different colors. A rainbow is a perfect example of seeing different wavelengths as colors. Violets are the shortest wavelengths, followed by blue, green, yellow, orange, and red. Red is the longest wavelengths of energy we can see. Energy the Earth sends back to space is in the form of longer wavelengths of energy. This energy is invisible to us because it's out of the visible spectrum. However, some creatures can see wavelengths that humans can't. For example, it's believed some spiders can see ultraviolet energy, which have very short wavelengths, while some reptiles can see infrared energy, which are much longer wavelengths of energy.
How do colors of the rainbow originate? A triangular prism and light source will be used for this activity. Rotate the prism while passing light through it until all colors are visible. The light that passes through the prism is broken into the individual colors. This is the same process that happens when light passes through water drops, forming rainbows. Now for our review questions. Which color has the longest wavelength? Do you know the answer? Yes, red has the longest wavelength. Next, which color has the shortest wavelength? That's right. Violet has the shortest wavelength. Next question. When the white light is spread out, what visible colors are produced? Do you have any idea? The answer? The white light spreads out into visible colors like red, orange, yellow, green, blue, and violet. For our activity, you need to get your notebooks or any piece of paper. Answer the question. How do colors of the rainbow originate? Write your answer on your notebook or a piece of paper. That wraps up our lesson for today. Thanks for watching. See you on the next video.